Another surface that you can very easily model and write down in a simple equation, there is a surface described as something like z equals a function of x and y, is a cone. If you want to write an equation that describes a cone that's specifically opening along the z-axis, up and down, you can write it by changing the equation of an ellipsoid in the following way. You can write x squared over a squared plus y squared over b squared equals to z squared over c squared. If you do this, you will get a surface that essentially will go up and grow in the direction of z, and the same thing on the bottom. You can see my incredible skills and why I became a physicist and an astrophysicist and not an artist. Now in this case, this is opening along the z-axis. But what if you want to open it along the y-axis? Then for that, you just need to manipulate this very easily and actually just change the variables. If you write something like x squared over a squared plus z squared over c squared equals y squared over b squared, then you will have something that will actually be opening up along the z-axis. You can imagine the rest. If you're curious to know what happens if I change parameters a, c, and b, you can try to think of it mathematically, or perhaps a more intuitive way of doing it is again to explore topcat, load the grid that I provide you and that you can download from Moodle and try to change it. First of all, you can just copy paste the examples I have where I've set a to 1, b to 1, and also c to 1. Once you have topcat open and the grid loaded, you can click on the subset option and you can create a new subset. You can call it whatever you want, but in this case, maybe calling it cone is a good idea. In the lecture notes, you'll be able to copy paste the conditions. Maybe some of the conditions are not very well formatted, but if that happens, you can just input them manually and you can always just change the values. So you can experiment on how it looks like. Once you do that, go to graphics, 3D, old plots, because they're much more intuitive, and the all gives you the full grids, and then when you define a subset, you'll be able to just highlight the points that satisfy that specific condition. You can also just create new conditions, new surfaces like a cone opening on a different axis, and by experimenting you'll be able to gain further intuition about exactly what matters. For example, trying to do something and then the result is exactly the same, trying to change the conditions and ending up, instead of defining a cone, you define the entire universe except for the cone, like here, or then figuring out how to display a cone opening along the Z direction. You can also just move it around, and if you click on the symbols, you'll be able to change colors. You can select back in and back out, so you can highlight the surface that you want to focus on. You can highlight the points that satisfy this condition if you're opening with Z, this condition if you're opening along Y, or this condition if you're opening along the X axis. You can flip colors with the snap of your fingers. It's easy enough. And you can obviously manipulate, and you can see this in 3 dimensions, like moving it like this, or like that, or like that. I would definitely encourage you to try to play with these conditions, plug them in, and change these values so you really understand what is happening to how the cone is opening up and also along the different axes. You should understand, of course, that if you put in a condition such as this, lower or equal than, you are not just looking at the surface of a cone, but the entire volume contained within a cone, in this case opening along the y-axis. What happens if you do this condition? Well, then you're essentially highlighting the entire universe except for your cone.